Hello, welcome to my channel. We will be doing question number 5, chapter 13 from vectors. Okay, the vector P and Q are such that P is this, okay. So this question has several parts, so I'm doing part A right now. Make it a little bit thin. This looks a bit too much. Okay, so the vector P is given as 11i minus 24j. Remember, I and j are unit vectors along x-axis and y-axis. Okay, and q vector is given by 2i plus alpha j. Okay, so the first part is that find the value of each of the constants alpha and beta such that p plus 2q is this thing. Okay, so what is going to be p plus 2q? It is going to be 11i minus 24j. This is p minus 2 and q is 2i plus alpha j. So if I simplify it a little bit, 11i minus 4i. Uh, uh, what did I do? Plus, so why did I put negative here? This is plus. Yes, sorry. Okay, 11i plus 4i. This is going to be 15i, right? 15i. Okay, and minus 24 and plus 2 alpha. So I can say this is 2 alpha minus 24, so many j's. Okay, and this is equal to, this is given by this expression. Sorry, this one. Okay, so this is equal to alpha plus beta times I and minus 20j. Okay, so find the values of each constant alpha and beta. So knowing this relationship, we need to find the values of alpha and beta. So you can see that coefficient of I are equal, so alpha plus beta must be equal to 15, and 2 alpha minus 24 must be equal to minus 20. Okay, this equation has only one unknown alpha. This has two unknown alpha and beta. So I will solve this one first. So let us divide the whole thing by 2. It will become alpha minus 12 equals minus 10. So alpha equals 12 minus 10. So this is equal to 2. Okay, we found alpha. So now it's easy to find beta. Beta is equal to 15 minus alpha. So 15 minus 2 is 13. Okay, so alpha is 2, beta is 13. This is part 1. Now let's do part 2. Okay, it says using the values of alpha and beta found in part 1, find the unit vector in the direction of p plus 2q. Okay, so we know that p plus 2q, this vector is given by, we have this expression. This one or this one, you can use anything. So alpha plus beta mean 15, 13 plus 2, 15. So this is 15i and minus 20j. Okay. So we need to find a unit vector along this one. So how can we find a unit vector? I need to find its magnitude. P plus 2q, its magnitude. So magnitude would be equal to square root 15 square plus 20 square. So this comes out to be 15. So a unit vector in the direction of p plus 2q is p plus 2q, p plus 2q divided by the magnitude of p plus 2q. So this is going to be 15i minus 20j divided by 25. So I can simplify it a little bit. 3i minus 4j over 5. Right? This is second one. Okay, let's do part B now. I will change the color. Okay. So part B says we are given a triangle OAB. The points A and B have position vector A and B with respect to the origin. Okay, so it's given that OA vector is A and OB vector is B. Okay. The point C lies on AB, and it is said that AB and to AC is 1 to lambda. Okay, so AB is to AC is 1 to lambda. Okay, so AB, so if the whole thing is 1, then AC is lambda. Okay, if AB is 1, then AC is lambda. Okay, keep this in mind. Now, find an expression for OC in terms of AB and alpha. Okay, so we need to find OC. Okay, what is OC? OC we need to find out. Okay, so you can see that OC can be written as OA plus AC, right? Now, OA is A vector and AC is lambda part of AB. Does it make sense or no? Right? Uh, so OC is, yes, A plus lambda times AB. Okay. Now, what is AB? It is A plus lambda times AB is B vector minus A vector. Okay, we have done this several times before. Okay, so this is going to be A and minus alpha A. So it is going to be 1 minus alpha times, sorry, lambda. I'm also calling it alpha A and plus lambda B. Okay, so OC is 1 minus lambda A plus lambda B. This is what we have to do, right? We are asked in part B, the okay, find an expression for OC in terms of A, B, and lambda. Okay, we did this thing. Okay, now again back to 10. Let me do part C now. The points S and T have position vectors this and this. Okay, the point. Okay, so basically there are 2 points S and T, and from the origin O, there are 2 vector T and S, and this is my origin. Okay, the points S and T have position vector S and T is okay, yes. The points O, S, and T do not lie in the straight line. Okay, we are doing that thing already. Given that the vectors 2S plus mu T is parallel to the vector. Okay, so what is this vector? 2S plus mu t. Okay, this is parallel to the vector mu plus 3 times s plus 9t. Okay, if this vector is parallel, if these two vectors are parallel, there must be some kind of ratio between them. Okay, ratio means if you multiply this coefficient of s and coefficient of t with the same number, both of them are multiplied by the same number, then you should get the coefficient of s and t. Only then they will be in a straight line, right? So I assume that there is some kind of multiplying factor here, and how can we talk about that multiplying factor? Uh, okay, yes, sorry. Okay, so okay, yes. So it means if I multiply 2 with that factor, it will give me this value, right? So it means the ratio between 2 and mu plus 3, it is the same ratio which is between mu and 9. Okay, does it make sense or no? Okay, so now I can solve this equation, find the value of mu. So it is going to be into mu plus 3 equals 18. I just did the cross multiplication. So this is mu squared plus 3 mu and minus 18 if I bring it on the left side equal to 0. And of course, the factors will be plus 6 and minus 3 equal to 0. So this is minus 18 and plus 30, yes. Okay, so mu equals minus 6 or plus 3. Okay. Uh, so we are given the positive constant. So we ignore this number and just take 3. Find the value of b. So this is our answer. Okay. I hope you understand everything. If you have any question, you can always ask me in the comment section. Thank you for watching. See you in the next video.